Today we'll be working on two-dimensional figures 4C, page 1 and 2. It says, which figure appears to have more lines of symmetry? Two or more lines of symmetry, sorry about that. So we're looking for lines of symmetry. Remember, lines of symmetry are lines where we can fold the figure and have two identical parts. So these two, the edges match. So that means this part and that part are identical. If I was to fold it this way, those two parts are not identical. So that would not be a line of symmetry. So if we look at our figures, we want which figure appears to have two or more lines of symmetry. So if we look at the star, if I was to fold that star, these two sides would be identical. So if I was to turn the star over this way, I know again, if I was to fold it this way, this side and this side would be identical. So I would have two identical parts. Again, if I was to fold the star this way, I would have two identical parts. Also, if I was to fold it this way, I would have two identical parts. So here I have two or more. So the star works out. So star could be one of my choices. Now figure S, I know if I fold it down this way, these two sides are mirroring each other. They're the same as each other. But if I was to try to go this way, if I was to make a line of symmetry this way, these two parts are not mirroring each other. They're not the congruent. So that cannot be a line of symmetry. If I try to go diagonal, these two parts are not congruent. So figure S only has one line of symmetry. So figure T, again, if I was to go across this way, this side and that side are congruent. If I was to fold those together, they would mirror each other. So that's one line of symmetry. Now, if I was to try to go down this way, this side and this side don't mirror each other. They don't match. So that can't be a line of symmetry. And try to go that way. These two are not a line of symmetry. They don't match. So figure T only has one line of symmetry. So figure U, if I was to go down the middle this way, these two parts are symmetrical. They mirror each other. If I was to go horizontally, this top part and this bottom part are the same. They mirror each other. If I was trying to go diagonally, I know that this is not the same as that part. They would not mirror each other. If I was to go the other way, they wouldn't mirror each other either. So figure 2 has two or more. Figure U, so these two have two or more lines of symmetry. So my answer would be figure R and figure U. Figure R and S, no, because S only has one. Figure R, S, and U, again, S only has one. Figure R and U only, yes. Figure S and T, no. So my answer would be figure R and S only. R and U only, sorry. The answer is C. Now B, Evan sorted polygons into groups. The polygons shown below belong in the same group. Which description best represents this group? So we have to find which description represents that group. All right, so we're looking for which description best represents this group. They all belong to the same group. So let's look at F, polygons with no perpendicular and parallel lines. So perpendicular lines are lines that form right angles. So if we look at our shape, we know this one can't be it because I can see right angles on the shapes. So this one has a right angle right here. This one has a right angle down here. And this one has a right angle right up here. So this one has two right angles, that one has two right angles, and this one has two right angles. So it can't be this one because it tells me no perpendicular lines, and perpendicular lines create right angles. And it also says no parallel lines, and I know this side is parallel to this side. And I know this side is parallel to that side, and this side is parallel to that side. So it does have perpendicular lines, and they do have parallel lines. So it can't be F. Polygons with two right angles. There's one right angle here, one right angle. So this one has two, this one has two, and this one has two right angles. So this one checks out. It could be that one. Polygons with two or more obtuse angles. I know this is an obtuse angle because it's greater than 90 degrees. See, it follows that one and it goes beyond that. So this is obtuse. This is also an obtuse angle. There's another obtuse angle and another obtuse angle. So this one has 4, so that's 2 or more, so that one checks out here. Here we only have one obtuse angle. This one's actually acute. So this one does not have 2 or more obtuse angles. It can't be that one. This one has 2 obtuse angles and 1 acute angle. So this one does meet it, but not that one. So it can't be H. Polygons with no acute angles. This one has acute and that one has, actually this is not acute. That is actually an obtuse. So this one doesn't have acute, that one doesn't have any acute, but this one does. That's an acute angle right there. So it can't be that one. My answer is G. Now we're looking at C. Hannah outlined a shape with toothpicks made of exactly 2 sets of parallel lines, but no right angles. Which of these could be the toothpick she made? Right, so I can make a rectangle, square, a rhombus, and a triangle. So which of these could be the toothpick shape she made? We know it has exactly 2 sets of parallel lines, but no right angles. So this one has 2 sets of parallel lines. That's 1, that's 2 over here, but it has right angles. It has 4 right angles. So it can't be the rectangle. Now the square also has right angles. So it can't be the square. Now the triangle doesn't have any parallel lines and it doesn't have any right angles. So it doesn't have any parallel lines, so it can't be the triangle. So it has to be the rhombus. This line is parallel to that line and this line is parallel to this line. And there are no right angles. These are 2 acute and 2 obtuse angles. So my answer has to be C. Now the last one, D. Angelina drew a quadrilateral that had no acute angles. Which of these could be the quadrilateral Angelina drew? So this one has to have no acute angles and it has to be a quadrilateral. Quadrilateral is a polygon with 4 sides. So I can make a rectangle, parallelogram, trapezoid, and a rhombus. All right, I want quadrilateral. They're all quadrilateral and no acute angles. This one has all right angles. So this one checks out. That one doesn't have any acute angles and it's a quadrilateral, it has 4 sides. Now parallelogram has 4 sides, that's a quadrilateral, but this one has an acute angle right here and an acute angle over here. Those are obtuse. So this one can't be my answer because it has acute angles. Trapezoid, it's a quadrilateral because it has 4 sides. So that checks out, but it has acute angles. This is an acute angle and these are acute angles. These are obtuse. So it can't be the trapezoid because it has acute angles. Now the rhombus has 4 sides, is a quadrilateral. Again, has an acute angle here and here. These are obtuse. So this one has acute angles. It can't be a rhombus. So my answer would be a rectangle. Now you work on pages 4C, page 3, 4C, page 4, and 4C, page 5 on your own.